Hello friends, today I am going to talk about the phase rule for non-reacting systems and reacting system. We will also discuss the phase rule with special constraint S. I have already made one video on phase rule where I have discussed the significance and application of phase rule. So we all know that phase rule allow us to determine the number of degree of freedom and it is denoted by F. So this is what it is, a number of degree of freedom, and we know that F is equals to C minus P plus 2. So which are the number of degree of freedom are the number of independent variables that must be arbitrarily fixed so as to establish uniquely the intensive state of the system, right? So if you know the degree of freedom, then you can identify or determine कितने number of independent variables are required to fix the state of that system, right? So we know that this is the significance of phase rule. So in a particular phase, the independent variables that can be specified are, so temperature, pressure, and phase. It can be a homogeneous phase or heterogeneous phase, can be anything, and C minus 1 mole fractions in each phase. So C minus 1 का क्या मतलब है यहाँ पर? So let's consider a heterogeneous system, and let's consider a heterogeneous system. And it consisting of C component, and these C components distributed in P phases. C components distributed in P phases. Now what it means, P phases? Like we have, let's consider one, two, three. So we have P alpha, P beta phases, so P gamma and so on. So we have number of phases, it can be 1, 2, 3, okay. And here we have number of components C1, C2, C3, C4. So this is the meaning, and similarly this is also distributed into in this. Here also C1, C2, C3, C4 and so on. So the composition of a phase containing C components is determined by specifying C minus 1 concentration term. This is because if the mole fraction of all but one of the composition in a mixture are known, the mole fraction of the remaining component is the difference between 1 and the sum of the C minus 1 concentration value. Since there are P phases, the number of concentration variables required to define the state of the system is, तो क्या कैसे define करोगे? Because we know that there are P number of phases and concentration is for component is C minus 1. So P in P phases C minus 1, because C minus 1 what it defines, that if you know we have number of components, concentration of these components 1 2 3 4 5 and so on. If you know the concentration or mole fraction of any one component, तो उसको कैसे define करोगे? C मतलब एक आपको पता है, rest you don't know. So total minus 1. So C minus 1, and all of them are present where? In P number of phases. So it should be multiplied by P C minus 1, right? And the temperature and pressure also to be specified in this case. So total number of variables, P C minus 1 plus 2. So this 2 specified it. This is what temperature and pressure is also specified for the system. So temperature and pressure are intensive variables, and they are same for all the phases, and P C minus 1 in P in bracket C minus 1 composition have to be specified. So now we look on to the relation among these variables. The relation among the variables are also called constraints. The phase equilibrium relation we have already discussed in our last video. The fugacity of a component is same in all the phases if there are alpha, beta, gamma, and so on. Phases are there. Then we know that fugacity of component I in alpha phase must be equal to the fugacity of component I in beta phase and fugacity of component I in gamma phase. So this is for all the P phases. So number of equations for a particular component is number of equations for a particular component is P minus 1. Of course, total phases are 1, and you know obviously कि किस phase में initially आपका component है. So what we do to determine the rest of the phases, total minus known. So this is your known phase and this is your total phases, right? And we have C component there. So this is P minus 1, and we have C components, right? So therefore total number of phase equilibrium relations, phase equilibrium also known as the number of variables that are not independent. And this is given by P minus 1. So these are the phases into kitne component hai? How many components are? C. So the number of degree of freedom is the number of variable minus the number of equations among variable. So degree of freedom is the number of variables. So number of variables are 2 plus P C minus 1, right? And minus the number of equations among variables. So these are P minus 1 into C. So when you solve this, so F is equals to 2 plus PC minus P minus PC plus C. So PC cancel, and this will be equal to C plus 2 minus P. So this is your F. Now this is the phase rule for the non-reacting system. Now let's discuss the special constraints. So special constraints are the additional equation among variables which have not been considered in the derivation of F is equals to C plus 2 minus P. So the number of degree of freedom becomes less due to special constraints. Let's take the example for azeotrope. If the azeotrope forms, the degree of freedom becomes less as the constraint xi is equals to yi, right? Because at azeotropes, when the azeotropes are formed, so at this condition, mole fraction in liquid phase and vapor phase of component I will be same, right? If azeotropes forms, the degree of freedom becomes less as the constraint xi is equals to yi has not been considered in the derivation f is equals to c minus p plus 2, right? So for binary for binary vapor liquid equilibrium system, C is equals to 2 because we have two component binary system, phases vapor and liquid, two phases are there. Then if you put into this, then degree of freedom will be is equals to 2 because C is equals to 2, P is equals to 2, so 2 cancel and then it is equal to 2. But if edge drops are formed, then what happens? X1 is equals to Y1. That means the mole fraction of component 1 in the liquid phase is equals to mole fraction of component 1 in the vapor phase. That means this degree of freedom will be क्या हो जाएगा? Less हो जाएगा by 1 because we know this thing component, right? So F is equals to here edgeotrophs are formed, right? So यहाँ पर क्या हो जाएगा? ये -1 हो जाएगा. Degree of freedom will be equal to 1. So thus, if special constraint exists, then degree of freedom are given by F is equals to C minus P plus 2 minus S, right? So where S is the number of special constraint. So अगर आपके क्या फॉर्म हो रहे हैं, एजिट्रॉप्स फॉर्म हो रहे हैं, तो यहाँ पर C is 2, right? Phases are 2 plus 2 और special constraint क्या है? Edgeotrough form हो रहे हैं. So this is your special constraint because mole fractions are same. So and then your degree of freedom is become F is equals to 1 in case of So we just had discussed the phase rule for the non-reacting system, and which is F is equals to C minus P plus 2, and this is for non-reacting system. Now what happens for reacting systems? So condition for chemical reactions to remain in equilibrium is that the chemical affinity of each reaction at the equilibrium must be 0. So condition for chemical reactions at equilibrium is that chemical affinity must be equal to 0. So chemical affinity of all the chemical reaction, that means if there are number of reactions or R number of reactions. So here I is what? It defines the number of reactions 1, 2, 3 and R number of reactions. If there is a R number of reaction, then the chemical affinity of all the chemical reaction, it should be equal to 0. And chemical affinity, as you know in simple understanding, is the extent of reaction. So chemical affinity of all the reaction must be 0, must be equal to 0 at equilibrium. So chemical affinity is equal to 0. So since at equilibrium all the reaction should have chemical affinity equal to 0, so they are automatically specified by the condition of equilibrium. So this must be again subtracted from the total what we got from the phase rule for the non-reacting system. So we had this F is equals to C minus P plus 2. So this is for non-reacting system, and for reacting system, the phase rule will be equal to C minus P plus 2 minus R. So in our today's video, we had discussed three important rules. The first one, the phase rule for non-reacting system, which is F is equals to C minus P plus 2. Second, we imposed a special constraint S in case of edgeotrophs. If there is a edgeotrophs are formed, then we know that mole fractions in both the cases in both the phases is same. So in this case, we need to impose the one constraint which is called S. So then your equation phase rule is become C minus P plus 2 minus S. So this is with phase rule with special constraint. With special constraint S. And the last one is phase rule for the reacting system, which is F is equals to C minus P plus 2 minus R. And R is what? R is the number of independent reactions in the systems. Hope you will be able to understand all three concepts. Thank you.